Yeah, today we will discuss recursion. Uh, in last couple of classes, we were discussing about functions, taxonomy of functions, and with respect to different kind of aspects like user arguments and prototype and all. So then, coming to recursion here, it's an alternate to iteration, I can say, right? Uh, Calling a function within itself is what's said to be the recursion. Calling a function within itself. Uh, it's an alternate to iteration, I guess, right? It is an application of stack actually. Data structure stack, right? Oh, we'll demonstrate directly with certain examples here in order to understand the recursion concept here. We'll take a factor of a number, write a recursive function to find factorial of a number. I'm directly writing the program and then we'll try to understand, right, the regression concept here. So here the return type I'm taking it as int because after you obtain the result, it's going to be integer rather, right? Function name I'm giving it as fact, right? And it is taking one argument, the number of which you want to find the factorial is going to be passed as an argument. As we know that if the number is 0, then what is the 0 factorial value? It is 1, right? 0 factorial is 1. If this condition is false, then obviously go to the else part, right? Or else probably onto the next statement, right? So where is we are having another statement called return of n into fact of n minus 1, right? This is the function, right? This is going to find the factor for our number rather, right? Will write the main function also. I'm writing the main function here itself. So I wanted to find factorial for a number, let us say some n, then this is right. Enter the number I'm saying. Then here I'm saying factorial of percentage d equal to percentage d. In place of first percentage d, I want to print the n value. In another one, I am calling a function fact of n. I am saying, right. Now this is the termination of the main function. Okay. Now let us try to understand this. See, as we know that the execution starts from a main, and you have a variable called n for which the memory will be allocated of 2 bytes. Enter the number. So enter the number is going to be displayed on the console first. This is the output. You have entered some value, let us say, for example, 5. Okay. So this 5 value is taken into n here. Then with the help of this printf, what exactly you are trying to do? Factorial. You are printing what? Factorial of, in place of this percentage, the n value will be printed. N value is 5 here, equal to, in place of this percentage, it is a function call. Now when the control comes here, it's a function call. Then what happens? The function has to be called. But then it is having certain arguments, so it will take the arguments and then first arguments are passed, then control will be transferred to the particular call function, right? So here n value is 5, so this value 5 will be transferred here into this n. So this n now is having what? 5, okay. And the control is transferred from here to here. Now you have to check whether n equal to 0. No. So then you come on to the next statement, wherein you have n into n here is 5 into, again you have a function call. When you have a function call of this kind, you know, within itself, it's said to be the recursion for which a stack is going to be allocated, right? So now what happens is that 5 will be placed here, temporarily stored in the stack in alongance with the operation, of course, right? Then again the function call is going to be made. But then next time when you are making a function call here, you are reducing the n value to 4, right? N minus 1, when you say n is 5 actually, 4. So the n value becomes here 4. Again 4 equal to 0 is false, so you come here, then 4 into, then what happens? This 4 into is going to be pushed onto the stack, and now again function call is made with n value been reduced to 3. So now it has become 3 here, right? So again, the 3 equal to 0, it's false. You come here, n into, so then what happens? 3 into, it is going to be pushed onto the stack, and then you are passing what? Reduced n value. Again, you're calling the same value, right? So now n becomes 2 here, you can see, and equal to 0 is false. So again, come here. You are having now again a function call n into, what is n now? It is actually 2 into, again you are calling the same function by reducing n value to 1. So now you come here to check whether it is 0. No. So you come here, then 1 into fact of, again function call. So whenever you have a function call within the expression, that expression value will not be evaluated until the function call is made. So that value will be pushed onto the stack temporarily until the last function call is made, so that once the last function call is made, the values are going to be retrieved by performing the operation specified on the respective operands in order to get the final value, right? So here what happens is, now when n value was 1 equal to 0 is false, so here you're coming 1 into, so again you have a function call, so that 1 into is pushed onto the stack, then fact of 0 now. With a reduced value of n to 0, you again calling the function. Now what happens? 0 equal to 0 is false. Now you have a return 1. So now what happens is, here the since the last function call it is, and it is done, and you got the final value out of it, which is only 1. So this is going to be multiplied with 1, and 1 into 1, that will be pushed onto the stack, and then this is going to be multiplied with this 2 into 1, then that is going to be multiplied with this 2 into 3 6, that is going to be multiplied with this, then this is going to be multiplied, and then the result which you obtain from it is going to be multiplied here, right? So it's going to be 120, and then that final value, which is nothing but 120, is going to be and then will be returned from this particular function call. So in place of this percentage d, what do you get is nothing but 120, right? This is how the recursive function call works. It's similar to iteration, like how we have implemented this factorial function earlier with the help of our loop. But then there we were explicitly mentioning, and we were able to know how the process is going to be done here. But in this particular recursive function, what happens? You are going to make the adjustment with the help of the instructions and the pushing and popping. All that required operations that are required to be carried out in order to get the final result is all being taken care by the system itself. So number of instructions you see from recursive point of view is very much less, and most of the operations are not required to be done explicitly. Rather, it is going to be done by the system. Basically, will make you the things more easy. So let us demonstrate this with the help of our online compiler here. Online gdb.com. So here I'm having demo for what? Recursion, right? Demo of recursion. Okay. We're having one function first here, recursive function named after fact and having one argument of integer kind. Okay. Then here we are checking this value of n whether it is equal to 0. If it is equal to 0, then we are returning what? 1. Else, we are having a statement where we are having an expression, and that expression operand is a function call of the same rather, right? Fact into n into fact of n minus 1. Okay. So now let us try to implement it in the main. So that I need a variable. I'm taking one variable n. Okay. Then here I am reading this value first. Enter the number I'm saying. Scanf. I'm reading the same. Help of scanf within double quotes. Percentage D, comma, ampersand n. Okay. So end semicolon here. Then now I wanted to implement this function here, and the result which I get out of it, I want to print the same with the help of this printer statement, right? So here the factorial value of percentage d equal to percentage d, where in the first place of percentage d we want n value to be printed, and in the second one where we want the result of the same, which is going to be here obtained from this particular function. So this function call I'm making here, right? So now let us try to execute this. Okay. Choose the language as C here. Size is larger only. Done. Run the program. So here a small mistake in printf, right? Double quote was mentioned. Sorry, colon before double quote was there, right? Enter the number. Now let us enter the number as 5. I hope you all able to see my output screen. So when I press 5 here, it's giving me the result factorial of 5 equal to 120. But how the execution is done is what I have explained before, rather, right? That way it takes care of the same. So here the n value is going to be placed in in place of percentage d, first percentage d, in place of percentage d. Uh, After equal, you have a function call. So this function call is being made by taking n value which you have written before, and now here function within a function. You're calling this function, right, within itself. So how long until the result is obtained, right? Okay. So I hope this is clear to all of you. Now, similarly, you can write the factorial program for sum of series and sum of squares and sum of cubes that I'm giving you as assignments. Note on the assignments here. I hope all of you are noting down. Write a recursive function to find first one sum of natural numbers. Okay. Then sum of squares of natural numbers. Okay. Then sum of cubes of natural numbers. So I hope you can all do this. Now coming to some more couple of functions I'll discuss on the recursion today. Write a recursive function to find GCD of two numbers. The GCD, we have already worked with iteration, right? Right? Yes or no? For example, if I have two numbers like this, n1 and n2, 24 and 36, how do we find the GCD of these two numbers? 36 by 24, 24 ones are 24. And then the remainder becomes a divisor and previous divisor becomes a dividend. Again, you continue the division operation 12 to the 24 until you reach the remainder. So the division operation for which you get the remainder. So divisor during that particular division is what the GCD, yes or no? So this is the mechanism that we have implemented before using iterative statements rather, right? So we have taken certain variables like rem equal to what we said. If here we perform n2 mod n1, right? So n2 mod n1, then what is that we will do here is until remainder is not equal to 0, you are continuing this operation. When you're continuing, your the n1 and n2 values are going to be changed, rather, right? So the remainder becomes n1, and n1 is going to become n2, right? So this is how the repetition you have done it until you reach the remainder is not equal to 0. Yes or no? So this is putting in a do while loop. Remainder is not equal to 0. You will be repeating this, and when you come out of this loop, the result which you get is in n2. Yes or no? N2 will be the result for you, right? This is how we have done before. Now we want to implement this thing using recursion. What are the programs you have done it using iteration, like for loop and while do while? You can implement all that using the recursion as well, but provided you need to have the proper instructions mentioned. Okay, but we'll see for a couple of programs, rather, right? Where you find its significance, of course, right? Yeah. So here I'm having now the recursive function for GCD, right? So the return type is of course the int, because after it obtains the GCD of two numbers is nothing but an integer itself. Then here I'm having the function GCD, so it is the function name, is taking two arguments n1 comma n2, right? See, while you are finding the GCD of two numbers, either of the number is 0, then non-zero is going to be your GCD. Yes or no? That we have taken as a condition while we were implementing, even using the equation as well before, right? So if let us say n1 equal to 0, what is the result? N2 is the result. So I should return what? N2. Yes or no? If n2 equal to 0, then who is the result? N1. So I have to return what? N1. But if none of them are 0, it means both are non-zeros, right? Then we have to go for the operation, right? So where what we are doing is we are having we are calling the same again GCD function, right? So we are calling the GCD function by passing, right? By passing in place of n1. N1 we said that the divisor, and n2 is the, let us say, the dividend. So in place of the divisor, what is it we are going to pass? The n2 mod n1, isn't it? This is what exactly, right? See, the divisor will get the remainder. Remainder is nothing but n2 mod n1. And in place of dividend, we are going to pass what? N1, right? So the same thing we can probably here do that. So in place of n1, I am passing the remainder value, that is n2 mod n1. In place of n2, I am passing what? The n1. Yes or no? You can see here, for n2 we are taking n1. So it means for n2 what is that I have to pass? N1. And for n1 what is that I have to pass? REM. Yes or no? REM is nothing but n2 mod n1, right? So for n1 I am passing the remainder out of the division of n2 n1, and for n2 the divisor is what? N1. So that's, and this has to be repeated. Fine. So I'm just having a return statement here. Return space GCD of, yes, return space GCD of n2 mod n1 comma n1. This is going to be repeated. That's it, right? So this is my function. Now I can implement it using the main, the same, right? What happens here is, in your passing, let us say n1 value 24 and n2 value 36. What happens? N1 first, n1 is going to be checked. It is 0, no. N2 is going to be checked. Is it 0? No. So you'll come here. You're having a function call again, right? GCD, same function call, n2 mod n1. 36 mod 24 is nothing but 12. So here 12 will be passed. It means n1 becomes 12 here in the next iteration. And n1 is going to pass to n2. What is n1 actually? 24, right? So that 24 is going to be passed here for n2, right? So this is how it's going to be done. Now n1 is equal to 0 is false, n2 equal to 0 is false. Then n2 mod n1 is going to be passed for n1, and n1 is going to be passed for n2. So then what happens? This becomes 12 and this becomes 0. And now when n1 is checked, it is 0, then n2 is going to be returned, which is nothing but 12. So 12 is the result, right? Let us try to demonstrate the same. First, we'll save this program. I'll go with the Google account here. This is recursive function, right? Recursive factor. dot c. Okay, and now let us try to create another project here. So here I'm having the demo for what? Demo. It's not demo. I can say it's a directly one I have already shown. So this is a recursive function, right? Recursive function for function to find GCD. Yes or no? To find GCD. Find GCD of two numbers. Of two numbers, right? Now let us have the function first. Int function name is GCD. I'm having two arguments, both are integer, int n1 comma int n2. Now here I'm checking the exceptions. N1 equal to 0, then the result is available in n2, right? So n2 should be written. If n2 equal to 0, then n1 has to be written. Yes or no? If n2 equal to 0, return n1. None of the conditions are true, it means both are non-zero. In that case, we are going with calling the same function, but with a change of argument. In place of n1, we are passing n2 mod n1. Okay. And in place of n2, we are passing n1, right? Now let us try to implement here in the main function int. You can take two variables a comma b, and now you are reading these two numbers first. Enter two numbers using a scan function. Percentage %t, percentage %d, ampersand a comma ampersand b. Now here you are calling this GCD function in the print function directly. Okay. So here we are saying GCD of what are those numbers? Percentage %d comma percentage %b equal to percentage %d comma, here we are calling the function. But before that, in place of first percentage %d, you want a, second percentage %d, you want b value to be printed. In the third percentage %d, you want the result which is going to be obtained from the GCD function. So for this function, what is it I'm going to pass? We're passing these two numbers a, b as arguments, of which GCD you want. Enter two numbers, it is asking for us 24 and 36. I'm giving. Then it is giving me GCD of 24, 36 equal to how much? 12, right? Is it clear to all of you? Yes, I hope this is clear to all of you. Yes. So how is the execution is going to be done as per the discussion that I have done before, right? You have taken two variables a b and you have accepted a b here, right? 24, 36. Then GCD of in place of this percentage a value that is 24, b value here. Then you are calling the GCD function by passing that a comma b. So the function is going to call within itself until it gets the final result, which is going to be when written here will be printed in place of this particular percentage. So similarly, you can have recursive functions for all iterative programs we've done before, right? I hope this is clear to all of you. Yes. Yeah. So let us try to uh, implement a couple of programs here. Recursion. See, binary search program you've done before. You can implement it using a recursive function also, right? If you look at the syllabus, we have mentioned a couple of programs to implement using recursion. So in the fourth unit now we have implemented GCD, factorial, sum of digits, and Fibonacci series. Okay, we'll try to implement these two as well. Fibonacci series have you done before? Yes, using iteration. First, we'll try to do it with the help of iteration, then we'll go with the recursion, right? So, what is Fibonacci series first? What is Fibonacci series? It starts with 0, 1, and the subsequent elements are sum of its two predecessors. Sum of its two predecessors. Got it? It means if I start with 0, 1, the next value will be what? Sum of its two predecessors is 0 plus 1. It's going to be 1. What could be the next one? The sum of its two predecessors, it means 1 plus 1. That is 2. So what is the next value? Is going to be 3. Next value is going to be 5. Next value is going to be 8. Next value is going to be 13. Like that. Okay. So if I consider the first value as f1, this as f2, then this value f3, how do I get? By summing up this f1 and f2. Yes or no? So f3 will be f1 plus, but in order to get the next element, that this is 1, that is that the next one is nothing but 2 here. In order to get this value, this has to become f2 and this has to become f1. It means current f3 should become f2 and f2 should become what? F1. Yes or no? F3 will go to f2. And this process has to be repeated. And how long you want to repeat, how many number of values that you want out of it, rather, right? So by putting this whole in a loop, right? You can put this in a do while loop, no issue. How long you want the f3 value? Let us say you want f3 value to be less than 50, or say less than 100, whatever it will be, right? So until f3 reaches f50, you will get the values like this. Okay, so you can do it with the help of a simple do while of this kind, right? So this can be implemented, using do while or for or while also, right? So and I want this to be implemented using recursion now, right?